Hello, welcome to lesson 66. Grace and Isabel. Two topics: simplification of radical expressions. I shortened our titles here because they're just so crazy long. And square roots of large numbers. These two topics are quite related, and I think that you will find them to be kind of cute and fun. We, last time, looked at adding things like we learned how to add like 3 square root of 2 plus 6 square root of 2 plus 3 square root of 5. And what we realized was that if the numbers inside the house, in the radicals, match, then we can add together the coefficients, just like we do with variables. If we have a different one, we can't combine them together. So keep that in mind. That's a basic rule of thumb. We're just going to make it a little bit trickier. Example 66.1 looks at a problem like this. Simplify square root of 18 plus square root of 8. All right, let me draw this line so we don't confuse those two. All right, now at first glance, you're going to look at this and go, oh, square root of 18, square root of 8, those don't match. Sorry, can't do anything. Which at first blush, that does seem like that's the right approach. But here's the thing. What if we broke down these numbers? Maybe we can simplify what's inside the radical sign first, and then we'll get a different result. So what we want to do is we want to break these down with our prime factor trees and see if we have any pairs of numbers that we can take out of the house and maybe have some different things left inside. So we're going to do prime factors of these. So right away I see 18. Well, I know that's 9 times 2. 2 is prime. 9 will break down some more to 3 and 3. And right away, my alarms go off and I go, oh, look, I see. Remember, for every pair of numbers in the house, I can take one of those out of the house. So I can see right away that I'm going to be able to change this. I'll pull out the pair of 3's, and I'll have just the square root of 2 left inside. See how I simplified it? Now I go over here to the 8, and I do the same thing. Let's see, that is 2 times 4. 2 is prime. That's going to break down to 2 times 2. And once again, I have a pair of numbers. I've actually got 3 of a kind, so you could circle any ones you wanted. But I've got a pair of 2's that I'm going to pull out, and then I'll have 1 left inside the house. I'm adding them. I just bring my plus sign down. And look, where before I had unmatching numbers, I now have matching radicals. So now I can actually add these, and I will get 5 square root of 2 as my final answer for this problem. Okay? So let's just jot down our steps here. Now that you've had a chance to see this, the steps, and it's really just one big step, is prime factor the numbers, hashtag stands for numbers, in the, and I'll make a radical sign. And I'll put a period there, and then the next step is bring out any pairs of factors. And remember, you have to have 2 in the house to equal 1 out of the house. So the square root of 3 times 3 equals just 1 on the outside. All right? And we did that here. Here was a pair of 3's, but we bring out just 1 3. So 2 in the house equals 1 out of the house. And our third step is look for matching radicals. And remember, that's exactly what we found here. They didn't match, but once we simplified them, they did match, and we could add them. Beautiful, yeah? Let's try one more, and then I will let you guys handle the third example. Here's example 66.2. And it has 8 times the square root of 27 minus 3 times the square root of 75. Well, they're making this a little bit more challenging for us, aren't they? Giving us some bigger numbers, but we're good. We can break it down. I wish I could ask you some questions here, but 27, well, let's see, that's 3 times 9. Circle that. I can break this down. That's 3 times 3. So I've got 3 3's in the house. That means I can circle a pair of them. 2 numbers in the house will equal 1 out of the house. But look what's different this time. this time we already have a dude hanging on the outside of the radical sign. Remember last time we didn't have anybody out there. So when we bring our 3 out, we multiply him by that. So now we're going to have 8 times 3 times the square root of the 1, 3 that we have left over in the house. So simplified again, this will become 24 times the square root of 3. All right? So look what we did. We changed this from 8 times the square root of 27 to 24 times the square root of 3 by pulling the pairs of 3 out and multiplying it by the 8. All right? So there's the first one. Let's try the second one now. I'll bring down my minus sign. 75 is going to split up. Let's see. That is 3 times 25. And look, good old John Saxon. He's given us lots of pairs of numbers and things that match. So in this one, we factored the number inside the radical sign. We found the pair. We're going to bring that out, and we're going to multiply it by the 3. So now we have 3 times 5 times the square root of, that's what's left, 3. And when I multiply those, I get 15 times the square root of 3. Well, look at that, you guys. Isn't that cute? We now have matching square roots of 3. So our final step is to add. So we can combine these now. We can ignore the radicals just like we ignore an x or y, and we'll simply do 24 minus 15, which is 9 times the square root of 3. Yay, we did it. Okay, that's the right answer. So now I'm going to let you guys hash this out. For example, 66.3, and you can work this one. It works exactly the same way. The only difference is there are 3 parts to it, but that's fine. You can handle that. I'll just show you what it looks like. Square root of 27 minus 3 times the square root of 18 minus 6 times the square root of 45. So just to remind you, prime factor those, pull out the pairs, multiply them by what's on the outside, and see what's left on the inside and whether you can combine things. All right, you guys go do that, and then meet me back here for the second part. Let's draw these boxes. That's the simplification of radicals, and come on back after you've done this example, and we will figure out how to find the square roots of large numbers. Okay, see you in a minute. I'm back, but I can't turn my paper. There we go. All right. The second part of this lesson is very similar. Example 66.4. They're going to have us simplifying, this time, much bigger numbers. Oh, here comes one of my kitties to say hi. Hi, kitty. How are you? He's standing. Could you see him? He was standing right by my paper, looking at my pen. All right, so we want to break down these large numbers. Okay, we've got this great big number in here. Hi, kitten. And I will give you guys a little trick. We know that we want to break this down into prime factors, but we also know that we're looking for pairs of numbers that we will be able to pull out of the radical sign. And when we have all these zeros, we can take a little shortcut. Do you see how we have an even number of zeros? We have 4 zeros in all. So we can break that down into 2 pairs of 2 zeros each. So let me just show you what that looks like. What we can say is that this number is 5 times 100 times 100. I know that is true because there's my 5, and then I need 2 zeros and 2 more zeros. See how I did that? Now, I know that I'm going to be able to take a 100 to the outside of my radical sign, and I'll be left with just a 5 inside. Do you see how I used all of these zeros to shortcut my prime factoring? I could have gone and done the whole giant prime factor tree, but I would have had a whole bunch of little numbers that I would have had to multiply back up to get my 100s. Hi, Sirius. You're really cute. He's walking back and forth. Oh, did you see his tail? It's really cute. So I can shortcut it by just using my, there he is. Hi, baby. You want me to pet you, don't you? Do you want to be on the algebra video? I think he does. Here's his tail. So this is a little shortcut step when we have big numbers that allow us to get to the answer much more quickly. Let me give you another example of it. Example 66.5. This one, again, our instructions are to simplify. This time it's 500,000. Now, notice that we have an odd number of zeros here. Hi, baby. He's back. He's back, he's back, he's back. Look, he's the algebra cat. So, what we're going to do this time is we're going to break this down. Again, we want our pairs of zeros. We have one left right there. Oh, look, he wants, oh my gosh. You're cracking me up, cat. So this time, we're going to have 50 times 100 times 100. Can you see him? Look, he's right there. Oh my gosh, that is so cute. How can I get anything done, cat, when you want your chin scratched? Oh my gosh, funniest ever. Okay, go be cute somewhere else, sweetie. So now our hundreds are ready. We're ready to pull out one of our hundreds, but we can break down this 50, and I'm going to go 2 times 25. That equals 50, and then look, that's going to break down to 5 times 5. So there's my prime factoring of my 50. So I'm going to be able to take out both a 100 and a 5. So this is how it's going to look. We're going to have 5 times 100 on the outside. I'm going to do it this way. I don't like the dots. And then inside we'll just have our 2 left. All right, so the final answer for this one is going to be 500 times the square root of 2. Sirius is totally into this, isn't he? He's really enjoying it. All right, so we use the zeros to help streamline the process. There's our final answer there. This was our final answer here. So I'm going to let you guys handle example 66.6. And that one, let's see, it's 40 million. What the heck? And remember, you want to create equal pairs of zeros and then prime factor what's left. All right, so with this one I would rewrite as 40 times 1,000 times 1,000. These guys, you already know what you can take out, and then it's a matter of prime factoring that one. And then example 66.7, you can do that one without my help. You'll be fine with that. So that is all for lesson 66. 2 simple, well, relatively simple operations involving radicals. So good luck with this one, and I will see you for lesson 67. Thanks. And Sirius says bye too.